Welcome back, guys. We are here with 3.4, the fourth section in chapter 3. And what you've seen so far is we've moved from what are inequalities. You reviewed that in 3.1. In 3.2 and 3.3, you solved algebraic inequalities, isolating the variable in an inequality. Nothing was really new there, very similar to the beginning of chapter 2. Except remember, if you divide or multiply by a negative, you must flip that inequality sign. Okay, so in 3.3, nothing's new. We're just going to get more complicated inequalities here. We're going to try more. We're going to keep solving. It's going to be great. So now we're going to do multi-step inequalities. Multi-step inequalities. So let's jump right into example again. Please have your notes out. Take notes, write down what I do here on the smartboard just as you would if we were in class. All right, so 7 plus 6a is greater than 19. You're going to solve this just like you solved the equations in chapter 2. We just have the inequality here. Okay, so how am I going to start this out? Well, I'm going to move the constant first. Again, we always move that constant. Combine it with the 19, and I get 6a is greater than 12. And just like you did with equations, your last step, go ahead and divide that 6a by 6. Again, that'll get a by itself. We get a is greater than 2. Again, nothing really new here. It's like the two-step equations we did in 2.2, just with an inequality. So again, pause the video if you are not ready to move on, copy this down, and we will go from there. All right, next example. 2 times x plus 2 minus 3x is greater than or equal to negative 1. 2 times x plus 2 minus 3x is greater than or equal to negative 1. Well, now we're getting a little more complicated here. A little bit different, stuff's new. Okay, so before we can isolate the variable, we need to combine our like terms and do some distributing. So what we're going to do is we're going to start out by distributing to these parentheses. Okay, because there's a plus sign in the middle, I will distribute to both the x and the 2. So when I do that, I get 2x plus 4. And then I still have my minus 3x is greater than or equal to negative 1. Where do I go from here? Well, again, before I'm going to move anything around, let's combine our like terms. I noticed that this 2x and this 3x have the same variable. And so I'm going to combine the coefficients. Namely, what I'm going to do here is 2 minus 3. Okay? So 2x minus 3x gives me negative 1x. That plus 4 just carries on down, and that is greater than or equal to negative 1. Again, before I'm solving the two-step inequality like normal, I am distributing and combining my like terms. If I'm simplifying the left side, if you will. Okay, final steps here. You're probably pretty good at this point. Go ahead and subtract 4 from both sides. When I do that, I get negative x is greater than or equal to negative 5. And at this point, you're probably on cruise control. Divide by, remember, if there's just a negative there and there's no number in front, it's negative 1. So divide by negative 1 on both sides. And I get x is less than or equal to 5. Because again, negative 5 divided by negative 1 is 5. Now remember, please note from what we did in 3.3, I have flipped the sign. Why? Because I divided by a negative. When you divide or multiply by a negative, please flip the sign. Alrighty, let's move on to our next example. I have 6z minus 15 is less than 4z plus 11. 6z minus 15 is less than 4z plus 11. Okay, so I'm trying to get z by itself. Now, if you feel like after our first two examples, you have a good handle on what we're doing here, what I want you to do is pause the video right now and try this on your own. You've been writing these down. Go ahead and try this, and then unpause the video when you're done. Check your work with mine to see if you get the same answer. So what I'm going to do here is there's a number of different ways I can start. There's no real simplification on either side I can do like the last problem. So I'll just go ahead and try and get the variables on one side, the constants on the other. Again, it doesn't matter where you start. You will still get the same answer no matter what. So what I'm going to do here is I will start by subtracting 6z from both sides. Again, it doesn't matter where you begin. That leaves me with negative 15 on the left side. 4z minus 6z leaves me with negative 2z. I still have my plus 11. Since I've chosen to have my variables on the right side, I will then move the 11 to the left side. And I end up with negative 26 is less than negative 2z as my inequality. Final step here, I'm going to divide both sides by negative 2. And on the left side, my negative 2's cancel, leaving me with z. Negative 26 divided by negative 2 gives me 13. But I divided by a negative, so my sign needs to flip, leaving me with 13 is greater than z. Again, anytime you multiply or divide by a negative, flip the sign. If you got it correct, great job. I am happy for you. If not, hopefully you see where you messed up. If you didn't get it right, but you're still confused where you messed up, please feel free to shoot me an email. Say, hey, Mr. Carter, I struggled with the third example in the 3.4 video. Can you help me out? And I absolutely will. All righty, moving on. Let's do negative 3 times 4 minus m is greater than or equal to 4 times 2m plus 1. Probably the weirdest looking one we've done so far. Again, if you're confident, if you're like, man, this video is pretty easy, go ahead and pause it, try it on your own. That's the next step here. But if you're not confident yet, I want you to go ahead and follow along with me. Do whatever needs to help, will help you. So what am I looking for here? Well, I can't go ahead and move stuff because these parentheses are standing in the way. So what I must do, as I mentioned earlier, is simplify both sides before I can go ahead and isolate m. So I need to distribute on both sides of my inequality. When I do this, negative 3 times 4 gives me negative 12. Negative 3 times negative m gives me plus 3m. Distribute the 4 and I get 8m plus 4. 8m plus 4. So then what I'm going to do now is I'm going to get m on one side. I will do this by subtracting 3m from both sides. I have negative 12 on the left. Those will cancel to be 5m, or they will simplify to be 5m, plus 4. I am then going to subtract 4 from both sides. This gives me negative 16 is greater than or equal to 5m. Negative 16 is greater than or equal to 5m. Okay? So last step here, I'm going to divide both sides by 5. Divide both sides by 5. And I get negative 16 over 5 is greater than or equal to m as my solution. Again, how could I check this answer? Well, the open side of the inequality is facing the constant. So I need to pick a number smaller than negative 16 over 5. Well, how do I do that? Well, negative 16 divided by 5 is, I know negative 15 divided by 5 would be negative 3. But negative 16 divided by 5 is a little greater, so I'll be safe in picking a number like negative 10. So if I want to check my work here, what I can do is plug negative 10 back into the original because it fits my solution and see if it works. So negative 3 times 4 minus negative 10, since that's the number I'm plugging in, is greater than or equal to 4 times 2 times negative 10 plus 1. And we'll see if this turns out to be true. Well, 4 minus negative 10 would become positive 14. And negative 3 times 14 would be negative 42. Let me check that in my calculator, though, just to make sure we're correct. Yep, negative 42. And over here we have 2 times negative 10, which gives me negative 20. Negative 20 plus 1 is negative 21. And when I do that, I get 4 times negative 21, which is negative 84. And thus my inequality is indeed true. Okay, so that's our final numerical example. Again, you see these increase in complexity, right? Now we're dealing with some fractions. We had some distribution to do, but I hope you're recognizing and seeing a broader process that's the same. So the last step, it would not be a Mr. Carter video if we didn't have some form of word problem to work through together, just because I know they're your favorite. Maybe they're just my favorite, but either way, we're going to work through this together, and we are going to figure it out. The school band is going to carry a banner in the homecoming parade. The banner length is going to be 18 feet. What should the width be if the perimeter can be no greater than 48 feet? So you know me, you know I love pictures. We are going to be carrying this banner. So I imagine we have this homecoming banner. Yay, Van Buren. So we got our Van Buren homecoming banner going on here, okay? The length is going to be 18 feet. We'll call this the length. Again, what I hope you know with rectangles is that whatever one side is, the other side must be as well. So this side will also be 18. Again, this is our length. And what should the width be if the perimeter can be no greater than 48? So we don't know the width, but I know the width on the left side and the width on the right side will be identical. And the perimeter totals 48 feet. Well, what's the formula for perimeter of a rectangle? Well, you simply add up all the sides. So when I read this, I see that 48 feet acts as that total I always look for. And if you're confused as to why 48 is the total for the perimeter, feel free to email me. Now, it also uses the phrase no greater than 48 feet. In other words, 48 is the max. Since 48 is the max, the open side of the inequality will face the 48. If you're confused on why that is, please reference the 3.3 video. I go into more detail about how the open side always must face the largest quantity. Because 48 is a max, the open side will face the 48. Why do I put the greater than or the equal to? Why do I put the equal to sign underneath? Because if it can be no greater than 48 feet, it doesn't say anything about not being 48 feet itself. So on the left side, I've got my total. I've got my inequality facing the right way. Now, what's making up that total? Well, it's the perimeter. We know perimeter is just adding up all the sides. So 18 plus W plus 18 plus W. Now, I have an inequality that I know how to solve. So what I'm going to do is I'm going to combine the like terms. I'll combine the 18s together. I'll combine the W's. What that's going to leave me with is 48 is greater than or equal to 36. That's 18 plus 18 plus 2W. That is W plus W. From there, it's a simple two-step inequality. Subtract the 36 from both sides. And I get 12 is greater than or equal to 2W. Finally, at this point, I will divide by 2. Divide by 2, and I get 6 is greater than or equal to W. 6 is greater than or equal to W. This is the conclusion of the 3.4 video. Again, we have taken more complicated inequalities and solved them for variables, both in word and just number format. If you have any questions, please let me know.